Welcome to Albatross Flight Dynamics Lab video tutorial 5, where we're looking at static response to controls. So from this video you'll see how to set up the aircraft so that the controls are correctly mapped, that the pilot gets the expected control output from control inputs. The first thing we need to do is set up the Flight Dynamics Lab Manager with the correct experiment. So if we select Flight Dynamics Lab Manager and then look on here, select the settings for experiment, and what we want is the static control response experiment. So click on that, leave everything else the same and run the simulation. And we've now got our aircraft fixed in space, and it's in a kind of wind tunnel thing. We've got some wind blowing towards the front and blowing backwards. We've got some little smoke trails from the wingtips just to help us visualize that. And looking at the aircraft, the blue arrows are the wind vectors, the green arrows are the lift vectors on the various panels, and the little red arrows are the drag. So first thing, before we move any controls, let's just try varying the wind to see if that behaves as expected. So we can, if we go to the wind manager, we can vary the wind speed, and as we increase the wing speed, so the angle of attack is exactly the same, but the lift and drag and everything else increases in proportion to that. That's kind of what we expect. We can also change the elevation. So if we make the wind come from underneath in our magic wind tunnel, so these blue arrows, wind going up, coming up underneath. And so what that now means is that the wing is at a positive angle of attack. You can see we generate a lot more lift when we're at positive angle of attack. The drag has also gone up, and same for the tail. Okay, let's have a look at what happens when the aircraft's flying in side slip. So set the wind speed 20 odd meters a second. That's a cruise velocity. 1 degree angle of attack, and if we change the direction of the winds coming from, so if we look head on to the aircraft at no side slip, the lift distribution is pretty much even, but as the wind starts coming from the side, we notice that the lift on the side which the wind is coming towards is greater than the lift on the other side. So this is the dihedral effect. More lift on that wing compared to that wing, so therefore the aircraft will roll with the starboard wing going upwards, which is correct. So if the aircraft starts side slipping to the left as we're looking at it, that wing will get picked up and the aircraft will roll back again. And we can go look from the other direction as well. The opposite happens. So if we start side slipping the other way, we get more lift on the wing going into the wind than the other one, and therefore it will roll out. There's not a huge amount of dihedral in this aircraft, but there's just enough to make it do something. Great, so that's the just the response of the airframe. If we now start looking at the controls, if we go to the aircraft manager, the important thing here is the control mixer, and when the pilot is flying the aircraft, he has a radio control unit, and the control inputs are in terms of roll, pitch, yaw and throttle, but that has to get converted into signals that actually move control surfaces on the aircraft. And you can see from this aircraft it's got an inverted V tail, so it's not obvious when you're doing pitch and yaw what exactly you do with the control surfaces. The pilot or the flight control system just cares that when it wants roll, it gets roll. But in terms of setting up the aircraft, what you have to do is set up this mixing matrix, and this would normally be inside the transmitter of the aircraft, or you'd have something similar on the flight control system. The main thing here is on this leading diagonal between roll and aileron, pitch and elevator, there's a kind of leading diagonal of terms. One of your jobs in terms of getting this aircraft set up for flight is establishing the signs of these control inputs. So they're kind of slightly randomized at the moment, but we'll see what they do as they are. Okay, let's start with the ailerons. So if I come over here and look at an aileron, so it's the left and right arrows control the ailerons. So I'm clicking the left aileron or the left arrow, and we can see that the left aileron, the port aileron, is going down, and the lift is increasing on that wing. And if we look on the other side, doing the same thing again, that control surface is going up and the lift is going down. So the mechanics are right, but if I was doing a roll left command there, actually what would happen is that the starboard wing would go down and the thing would roll to the in a clockwise sense, which is not what I wanted. So what I need to do is swap the controls round. So this starboard aileron is going the wrong way when I do my roll input. So I'm going to put a negative term there. And I have to click back in this window to make the controls work. Now it's going the other way, so now when I do a left, try to do a left bank, it goes up, but the other control surface is still going the wrong way, so they're actually both going down. And this is fairly common on setting up aircraft, that you have to spend some time at the beginning making sure the controls are right, and many aircraft have been lost because the controls have not been set up right. Okay, so I'm reasonably happy with that. Let's look at it from the front. So back is easier. I want to make it roll anti-clockwise as we're looking at it, so I'm doing a left roll input, and as I do that we're getting more lift on the starboard wing, less lift on the port wing, so the aircraft is going to roll in an anti-clockwise sense, and that's the configuration we want. So if I do the pitch input now, and so it's the arrows on the keyboard, and so if I sort of pull back on the stick, I can see that both of our rotavators go down and the lift increases on the surface. So that's correct from a mechanics point of view, but that means there's more lift at the back, so that actually the nose is going to pitch down. So I need to be able to reverse that. Looking at yaw, so it's A and D on the keyboard. I'm applying yaw, but actually I'm getting the same increment in lift off both of those, so that's not going to do anything to my yaw. So what I need to do is sort out in the control mixing on the yaw channel, such that when I do a yaw input, the rudders both go in a way that gives me the correct sense of yaw. And then lastly, looking at flaps, so I hit the F key. We've got one flap going down, the other flap's not moving at the moment, but the starboard flap is moving in the right direction. Flaps kill aircraft. If this happened in flight, you got an asymmetric deployment of flaps like that, the aircraft would just roll on its back when it was coming into land. So getting things like flaps sorted out that they operate symmetrically is really important. Okay, that's enough for you to understand how to set up your aircraft, change the wind on it, verify that the basic airframe is performing as expected, and then you can go through using the input mixing matrix to set up all the controls for your pilot so that they all behave in the correct way.